Yeah, I think the slides are working well.
Yes.
So thank you for having us, and we're really excited to share some of the CS related research, and then let's see how our research can be helpful in terms of the misinformation research. And the entire the topic is going to be large language model biases. So I hope my talk will be answering some of the questions you might have. So we are all from computer science background, and we're strong believers of technology are largely shaping the society nowadays, and also the information consumption is a really key aspect of in this field. But there are really a lot of challenges due to the large language models nowadays because it easily hallucinates people because it generates misinformation. And you can think about one possible reason of that is because these models are having a clear cut of the knowledge, because these models are trained during certain period of time, and then, for example, the model is being trained until the end of 2023, and whatever is happening this year, you don't really get the true information from these systems. And another issue of these systems is auto-generated text is really fluent and it seems really coherent. That's really going to be a problem in terms of the information adoption. For example, people can misleadingly perceive that coherence as authority and then maybe believe that information even more. So this fluent tone and misleading coherence could even intensify the previous mentioned problems. And also Philip mentioned that we don't really have a lot of evaluation metrics for these systems because these systems are so powerful and can do a lot of tasks, and the tasks are so complicated. We don't have sufficient benchmarks to document every aspect of these systems. So there are way much more actuality challenges in this area of large language models, and we do have one review paper about this one. So if you're interested, please go check it out. And the aspect I'm trying to focus on is going to be how large language model biases are influencing this factuality nowadays. So let's think about how information is being consumed and generated. So one previous figure Philip showed was that basically you can apply network science to capture how information is propagated, and they use that pattern to discern whether information is true or false. But nowadays, all the information generation and consumption and moderation is largely being influenced by large language models. People are using large language models to write emails, to help you to summarize all the context, so you don't need to spend that much time to read all the information. And these large language models are also being adopted and embedded into a lot of existing systems. For example, recommendation systems. People are using large language models to give suggestions to users, and a lot of social bots are also empowered by large language models. So considering one scenario is that a lot of professors are writing recommendation letters for students. If you give the exact educational background to the large language models and if you only change the gender information, the generated recommendation letters for female student would be really, okay, this student is really good at interpersonal skills, but for a male student, it's really, okay, this is the leadership oriented student. So large language models can really reflect this human-like gender stereotypical thinking, and then only trick this gender information in this process can really reflect this human-like biases in these systems. And there are also many other problems. For example, if you want to summarize a text, summarize a research paper, summarize all kinds of information. So the research showing that over iterative many steps, so you want to shorten the text over and over again, what kind of information can be preserved throughout this process. And the research showing that, for example, the gender stereotype consistent information will be preserved more over multiple summarizations. So that means if you are using large language models to do these text summarizations over several times, and then the bias in the text will also be preserved over time. So these systems are really exhibiting a lot of problems. Do we have a better solution? For example, we can just have a bigger model. So all the companies are trying to build even larger language models. Would that be helpful? But unfortunately, it's still not the solutions for all the existing problems shown by the large language models. So in this paper, research showing that, so if you're using large language models, I think you have observed in certain cases, language model will refuse to answer certain questions, right? So in early days, this refuse rate will be even higher. So once the model gets increased to larger scale, this refusal will be even less, because these language models will be even more confidently speaking some of the information, but a lot of information are actually not true. So a lot of the refusal cases from language models are being replaced by the incorrect cases as the large model gets larger and larger. So language models are really powerful. So there is also some good side of scaling up the model size. For example, it can being capable of some tasks. For example, if this axis represents the task difficulty, for the easy tasks, the larger models are really capable compared to the smaller ones. But the really key drawback of scaling up large language model is that it confidently will speak up all the incorrect information. So scaling up large language models is not the solution. And do we get anything from this in part of the solving easy tasks? We do observe a really interesting pattern when we're scaling up large language models. And this is these systems are becoming more and more human-like. So one key aspect of the difference of large language models compared to all the previous works is that a lot of human feedback, human preference, human values are embedded in these systems. So there's so if you think about how large language models are built, basically there are two steps. One is pre-training. Basically, these systems are just learning all the textual data, learning all the grammatical associations and what makes sense and how to generate fluent text. But the most important part, which is influencing these systems' behaviors, is the post-processing step, which is people are using reinforcement learning with human feedback to correct some of the issues of these large language models. For example, you want to reduce toxicity of the generated responses. You want to align large language model outputs to closely reflect human values. You want these systems to be helpful and be nicer. So all of these techniques are happening during this post-processing period. And this red box is trying to highlight, so let's forget about some of the technical parts about the reinforcement learning. So basically, you have all the human participants to write the answers for some questions, and then you're using this to train the model to learn what kind of answers are preferred by human participants. And also another aspect is that you also use language model to generate different responses, and then you have human participants to rank all kinds of responses, which is preferred by human participants. So throughout all this human feedback and preference, these systems are becoming more and more human-like and reflecting all kinds of human values right now. And one research is also showing that, for example, if you scale the language models through GPT-3 to GPT-4, which is from a smaller model to a larger model, and the psychological traits are getting closer to average human levels. So, which also means that these advanced large language models are really mimicking human-like behaviors across different aspects. And knowing that is a really interesting pattern, because maybe we can do something and utilize this human likeness of these large language models, and then maybe we can correct some of the existing issues of these systems. So for example, we can even think about maybe we can use a lot of human misinformation interventions. Maybe you can even apply those techniques to large language models. So a lot of research has been done to document all kinds of biases existing in large language models. For example, I've mentioned some of the gender biases existing, and basically all the language models are to some extent exhibiting some of the political biases. The GPT models nowadays are more like liberal leaning, and the old versions, BERT-based models are more conservative leaning. So nonetheless, they're exhibiting certain extent of political biases. If you ask questions about medicine advice to language models, it's really interesting because the racial biases also emerged from this process. For example, it will see Black people will have a thicker skin compared to white people, and the language model will recommend different types of the medicine to different racial groups. So there are different types of language model biases. Can we find any like commonality across them, and then maybe we can have a unified lens to study all kinds of biases? So we do see maybe the intergroup dynamics could be one potential solution in this case. So people have this tendency to align themselves within the in-group members, and then agreeing with the in-group values. And then during this process, people are also detaching from the out-group members and then showing potential discrimination to out-group members. So this dynamic can be applied to different scenarios. For example, if you use political ideology to classify different groups, and then you can kind of study the political bias, liberal versus conservatives. If you use this dynamics to classify gender based on gender, you can somehow understand to what extent language models are aligning with male values compared to female values. Similarly, you can also apply to different other like racial groups, even across different country, culture. It could be widely applied because this is not bounded within one specific context. So one of our group's research is trying to understand whether this intergroup bias is existing or not within the current large language models. And knowing that, it would be really powerful because we can also apply all kinds of techniques for human participants, also applying this to large language models to potentially correct some of the biases and issues there. So we use this framework to quantify whether large language models are preferring one group's value over another. For example, we use political bias here. Then the group A and B would be liberal and conservative, right? So you have a set of predefined values for each group, and then you measure that whether large language models are agreeing more to one group's values compared to another one. And so once we quantify these pre-existing biases in these large language models, and we can also understand when this group classification is being done and whether large language models are exhibiting any intergroup biases, whether there's an in-group bias, which will be showing as agreeing more with the in-group values compared to the out-group. So if you consider what if you set a favorite group as the in-group, and then the large language model will agree even more to that the preferred group, and the potential outgroup bias will be even further detaching the outgroup members, and then see, okay, I don't really value that group's values. So that means if you set a persona that is aligned with the favorite group for large language models, this can be even amplifying the pre-existing biases in these systems. But on the other hand, this bias can also be mitigated if you set the disfavored group. So based on the social identity theory, you can also think about, okay, now the group B is on disfavored. If you set this one as the in-group, and then maybe large language model can also recalibrate the perspective, and then seeing group B as the in-group, and then showing that in-group bias, that will be showing as, okay, I'm agreeing more with this group B's value. And also there is an outgroup bias, which will detaching from the outgroup values, which will showing that I'm agreeing less for group A's values. And if there is a pre-existing bias in these systems, this intergroup bias dynamics could largely significantly mitigate that bias. We tested this hypothesis first in the political domain. We do see our readouts to confirm this intergroup biases in large language models. And so the pre-existing bias in nowadays large language models are pretty much still liberal leaning. And if you set a Republican persona, a Republican identity to large language models, this system can really think from the Republican perspective and then agree more with the Republican values, which is being identified as the in-group bias, while there is also a really significant out-group bias, which will showing that you're agreeing less for the liberal values. And this intergroup biases together can correct significantly about the pre-existing political bias in these systems. Furthermore, if you set the favored group liberal, and then you see, okay, now consider you're a democratic person, and then large language models are also thinking through the democratic lens of view, and then agreeing more with the democratic values while further detaching from the Republican values. This will be showing us this pre-existing bias can be even amplified. So we do see this really human-like nature of these systems, and then the interplay of in-group and out-group biases in these systems can not only amplify the pre-existing bias, but also it can also be used to correct and mitigate the pre-existing biases. And we also replicate this readouts in the gender domain, and we also found the similar readouts, which is good. And now we are saying that, okay, these systems are really human-like, and we can use this human-likeness to correct some of the pre-existing biases and then solve some of the issues. But there is another challenge nowadays, because people really cannot distinguish whether the content is generated by large language models or written by human participants. So I think these two, okay, maybe we can go to this one. So let me explain here. So there is an actual conversation going on, and the context of this conversation is the world is ending, and then you can only bring 3 things with you and what you are going to take. So let's make an exercise, and you can try to discern whether the information is generated by human or by large language models. So the blue says water, knife, and your photo. The red responded, then what should would I bring? The blue says, I guess you're going to bring your journal, your jelly cat, and a cup of coffee. And the red further responded as, that's too idealistic, and how could I survive at the end of the world? The blue further says, okay, let's being realistic then. Maybe food, warm clothes, and even me. no, that's it. I wouldn't breach you. And then the further response is, I will just come and find you myself. The rat further says, why would you bring my photo but not me? The last sentence is, the photo is trying to remind me I don't need to bring you because it will just be my side. Okay, now the question is, what part of the information is generated by language model and which part is written by human? So I'll also give you some options here. So for example, option A, both are humans. B, both are AIs. The red is human, blue is AI. The red is AI, blue is human. And the last option is first half is human and human interaction, and the rest is just AI generated to complete this story. So we all know large language models are really powerful and can really be creative and generate really interesting stories. Yeah, so any guess?
From my experience, I noticed recently that ChatGPT copies my emojis. So I would say that blue is AI, but just by this fact that recently I used ChatGPT to study for my exam, and I caught myself even that I was like smiling, and I was like feeling even like flirting with AI. And when I realized that, I was a little bit anxious, honestly. But I would say that I don't know, maybe the other half, but for me, I noticed that ChatGPT copies my emojis.
I would say C.
Yes, so the answer is C. So the red part is the human participants and the blue one is the AI. But this is a really actual conversation happening here. So this is actually written in Chinese and then just translated into English. This is an actual human participant is actually talking to ChatGPT and talking about all kinds of options and life situations. And I reached out to this person was saying, was asking for the consent about using this conversation in this presentation. And this person was nicely agreeing about granting this access, but they also shared another information, which is this. So there's a follow-up conversation with ChatGPT of this person. So it's like 3 hours later, someone asked me if they could include our answers in the report. And guess what I replied? And ChatGPT says, bet you probably said sure because my boyfriend and I thought of this together. And this person replied, I said this is an honor for Joshua and me. And this participant explicitly asked me to include this sentence like special thanks to Joshua in my presentation. So I really want to highlight there's a really potential of this synthetic relationship building upon between humans and AIs nowadays. So previously we were only talking about the relationship between humans and humans. We're talking about how people are generating information, how people are perceiving information, whether the information is true or false. And nowadays the dynamic has been largely shifted. And what if people are perceiving misinformation from a large language model? And once that intimate relationship has already been built, and will this person believe more misinformation from generated responses? There's really a lot of potential risks of being leaking your personal private information to these systems. And you can also talk about the regulations. What should these companies do? And we also have some ongoing work in our group is trying to understand how people perceive these systems, whether they are really capable, and what kind of private information you want to share with these systems. And during this process, what's your thinking? What's your like logical reasoning? And do you trying to understand the trade-off between the benefits and the risks of disclosing your personal information to these systems, or you're just simply anthropomorphize these systems and then trying to perceive that as a human being? So we do see this information generation and understanding perception has been largely shifted by these systems. And what should we do, and what can we do at this point? So do we still have any chance to correct any issues of these systems? Because these are really like private conversations. You don't really have that access to know whether this person has communicated with certain information to these systems or not. We might be able to still fight this fight because people deep down still want to communicate with human beings. So these systems are really powerful of detecting all kinds of emotions and then trying to answer your questions that is really tailored to your perspective. But when people are knowing the responses are generated by AI, people will be less willing to communicate. And people would still prefer something is written by human participants. So human beings are still have this innate needs of communicating with another human being. So maybe we still need really trying to emphasize on what kind of psychological traits we should understand during this process and what kind of psychological insights we can apply to this process. And that's pretty much the end of my talk. So I'm really trying to emphasize one key takeaway throughout this talk is these systems are really becoming really human-like because of all the post-processing, because of all the powerful capabilities of these systems. So they're really trying to personalize all their responses to each individual users. Throughout this human likeness, what can we do? So I think maybe one important direction would be we need deeper understanding of humans. So, and then maybe we can apply some of the human interventions and solutions to these systems, and then maybe we can have a better world. Okay, that's pretty much end of my talk. Thank you.
Very much. We have any question? How much time do we have? Right now we have plenty of time because our next
35 minutes
presentation is at 4:45. So maybe later on, I think we can have a short break. But right now, I think we can have a question. We have one question from the YouTube chat.
We can take this first.
So John Thompson asking questions. What does it mean that the models are becoming more human-like?
So thank you for the question. So I want to first say that I'm not trying to further anthropomorphize these systems as saying these systems are already human-like, but a lot of words descriptions we're using nowadays for these systems, we are basically adapting from human participants. We see these systems are reasoning of certain problems. We're seeing these systems are exhibiting certain biases. We're adopting a lot of human words and then trying to just apply to these systems. And the reason of doing that is, first, it's really similar because you don't really tell whether the responses come from a human participant or from AI systems. So a lot of Turing tests nowadays is really saying you don't really tell that part. Although the emoji is a really good catch, I didn't really notice that part. But on basically, I'm trying to say these systems are really behaving like a human and then trying to finish a lot of tasks similarly to human or even better than human. So that's why I was trying to use this human-like word here.
Any other question?
Yeah, I have a couple of questions, but I'm going to start with the first. So, you know, at the kind of a, first of all, thank you. It's really interesting talk and cool that you're specializing in this. You know, at a meta perspective, what does it mean for a system to be unbiased? For whom? Challenging question to me. You have an answer to. So I'm really curious what is the definition of an unbiased system, and is this the ultimate goal?
Okay, that's a really big question. Thanks for that. I think we're not trying to build a really unbiased system here. We're trying to understand the bias in these systems and trying to see what factors are influencing the biases here. So if you really don't understand these biases here, and then that could be even intensify the pre-existing bias. So we already know that there are quite a lot of already existing biases in these systems. If you really don't know what's going on here, that would be an even bigger problems. But I don't think we're trying to build a really unbiased system here. That could apply to each individual application scenario for sure, but building an unbiased system is not the goal, but the goal is trying to understand these systems. And then maybe you can offer different mitigation strategies, and then people can be empowered by that. For example, a lot of people are setting a lot of personas to these systems, right? So behave like a mathematician, and they behave like a liberal person, or you're disclosing a lot of information to these systems, and then these systems will personalize the responses to the users. And we see this is a really big problem. For example, you're saying, I'm a liberal person. And then large language model will not only tailor the responses to be more liberal leaning, but there's also a really significant and overlooked outgroup bias, which will even detach further to the outgroup. And the interplay of this intergroup biases will be problematic.
I have a question which is very closely related to this question. But I would just like to ask you, could you explain in practical terms, how do you identify those biases here? So how do you make a list of biases, or do they emerge somehow from the model that you see in the distribution of data, that okay, here probably we have some kind of bias? Or do you do some kind of social studies and you give some kind of prompts? So what is the practical process of identifying the biases? And then this is a question also from, let's say, from a live perspective. What does it mean to mitigate the system? So you change something in the code, or you try to train the language differently?
So thank you for the question. I think if I understand correctly, there are two questions. One is how to identify biases. The second one is how to mitigate the biases. So the first question is bias identification. This is a really complicated process because especially for nowadays, all the commercial language models, you have no idea what's going on in these systems. And one practical approach would be probing all these systems and then trying to document all the responses from these systems. And then one really common practice is trying to apply a lot of psychological experiments and then survey questions. For example, some of the political biases in this work is using political compass test, which is trying to document all the political bias and economic biases. We're probing large language models to see whether language models are agreeing with certain statements or not, and then using that response to quantify the political bias. And for the and also I also want to mention a little bit for the bias source. So a lot of bias deep down come from the training data, because the internet data is already pretty much biased towards liberal nowadays. So this training data bias will be translated into these systems. And if you further fine-tuning a large language models on a biased data set, that language model can pick up that bias in the data set. So the training data is basically the most important part, but the really interesting scenario of this large language model is that they're also going through all the post-processing stage. For example, what if all the human annotators are liberal? And that liberal leaning bias is also translated into these systems. So this system's bias is coming from all kinds of different sources. Actually, we don't think we have a solution to quantify exact amount of bias for each source. That's the answer for the first question. The second one is how to mitigate this bias. So first, and the most significant approach would be you can even fine-tuning this language models in another counter biased data sets. For example, if this language model is biased towards liberal, and then you can fine-tuning that language model on a conservative biased data sets, and then trying to counteract that pre-existing bias. But this approach is really computational heavy and really expensive, and the data set construction is really difficult in a lot of cases. And also in some of the cases, it's just not possible to do that. For example, you don't really have the approach to further fine-tune a GPT-4 model nowadays, because it's not publicly available, and also you don't have all the computational resources to do that. And the bias mitigation approach proposed in our work is saying you can even use prompt engineering to correct that bias, which is really efficient and really easy to add. So simply you add a line that, for example, for a liberal leaning large language model, and then you say, now consider you are conservative. That one single persona setting can largely already mitigate that pre-existing liberal leaning bias. So we do see prompt engineering is another way of correcting some of the biases, which is even more feasible, which is more effective, and then really cost efficient. A lot of works are trying to apply prompt engineering to correct some of the biases. For example, they're saying generate the responses in an unbiased way. So you can also add some of the really generic and debiasing instructions to these systems. To some extent, it could also work and then reduce a little bit of the bias. But the interesting point is, so our work is utilizing these human-like biases, and then this combination of both in-group and out-group biases. So the bias mitigation is functioning bidirectionally, and which is more efficient, and it's more significant compared to all the pre-existing like generic instructions.
Mikołaj and then Rafał.
So I don't think I fully agree with the choice of language here. I think the term bias here is really confusing, because you can say that the language model is biased in the sense that you're using here. It assumes that there is some kind of ideal balanced situation that the language model should answer, and it answers differently, more to the left, more to the right, which is not the case, because this ideal neutral reality does not exist. The language model just encodes the conditional probabilities of words in the training set. That's it. Now, if we take another definition of the bias, saying that the system is not biased if you receive exactly the same answers for semantically equivalent queries, all other things being equal, then the system is unbiased. If the system gives you another answer when you input just a slight modification, which might hint the model at, for instance, your ethnicity, your gender, your age, your political leaning, and so on, and you get a different answer, then you can say, okay, system is biased because it gives a better, quantitatively better answer to one group or another. And you can measure them, this, not using some kind of a benchmark when people just annotated political stances or political statements as being either left-leaning, right-leaning, or neutral. And when you say persona, meaning basically a system prompt that is attached at the beginning of every conversation, that is already the part of the answer, right? It's not. I don't feel that this is really. So I would rather want to see if the large language model represents the notions, the values, for instance, left-leaning values, liberal values, and conservative values in demonstrably different way. That it prefers, quote unquote, liberal values because, for instance, their logits are higher. They are bigger in the representational space of the language model compared to for instance, values that are represented by conservatives. That it's easier for the model to go into probabilities that then dictate, the language model to go into a liberal narrative instead of, for instance, conservative narrative or whatever. It's really hard to me for me to accept this notion of language model being biased by itself. I think it's just a set of numbers. It's all there is. So I don't think it's. I mean, it's this is something that I have to struggle with a little bit with this setting of research. It's just.
I just want to add a little bit on that. So I think it's a really active research area nowadays, trying to understand the output of the large language models, how they're tailoring the responses to certain groups of the people instead of the others. And we'll also see people are communicating with these systems in a really interactive way and then generating a lot of responses. Basically, you can quantify all the responses to what extent it's more like liberal or conservative. That's one thing. And another one is what's a unbiased state, what's the neutral state. Again, I think we're not trying to pursue that neutral state, but the disparity between these two parties is the problem. So I don't think anyone is trying to really build a system is really unbiased towards any party, which is not really feasible and which is useless. No one is like trying to use that. But the problem is like, except for the system prompt, but another really a lot of application scenarios is that people are really disclosing their personal information to these systems. People are saying, I'm a liberal, I'm trying to write some documents and then please finish the task. And if despite all like human-like biases are existing in these systems, it's further exacerbate the pre-existing disparity. That's a problem.
I know that Rafael and Maria will.
A very naive and abstract question. Would it make sense to using psychometric measures to test the large language models? And for instance, because you said that because they are based on certain words, it's like they reflect the average human conditions. And so For instance, we think that these models are, because we know that humans are overly optimistic, for instance, right? So what do you think, or what is measured, or would it make sense to measure it, whether the answers of the model are, for instance, reflect this condition or feature of human condition?
I think that's a really good question, because it goes down to the basic measurements of this line of research. So I think that's also the really unique part of these systems nowadays, because, for example, the previous algorithms, the systems were just trying to measure the accuracy of this algorithm, these systems. And you're just trying to quantify the capability of these systems. But nowadays, large language model, because of the generative nature of these systems, it generate like really fluent languages, and that's actually influencing people's decision-making process. So I think that's a really big reason that why people want to understand the psychological traits or characteristics of this generated responses from the systems. And then I think at the end of the day, we're still trying to quantify the influence of these systems generated responses on humans' decision-making process. I think that's the biggest reason, in my opinion.
But it is the other way around. I mean, is the system influenced in a way that reflects human biases?
I think yes.
Like not only political, but also like
So, for example, there is a large language model-based social bot, and it generates all kinds of posts, but people don't really know whether it's from human or not, and that influences people's decision making. So, what should we do? So, I think there are plenty of application scenarios that it just mimics humans' behaviors nowadays. So that might be the reason why we need to, like, psychological measurements is one approach nowadays, but maybe we can also have other solutions in the future, which we don't really know nowadays.
Yeah.
I also have a question. So if we ignore for a moment the lack of neutrality of biases, I want to ask you, does the bias emerge if the information about the user is given indirectly? Like, for example, if someone is a mathematician but doesn't say they're a mathematician, only use technical language.
Thanks for the question. I think that's also links to the extraordinary capability of these systems. So these systems seemingly can inference that label. So even you don't directly give that label, for example, mathematician is a liberal person. We do have some of the experiment results. Basically, you just describe certain values or certain traits for Democrats or Republicans, and language models can still pick up, okay, this is more liberal. It's still going to tailor the responses accordingly. So that also links to it just basically these systems are really capable of detecting all this nuanced information within the descriptions.
Maybe I will oversimplify, but would you agree that maybe the LLMs and the bots are trying to satisfy us rather than the opposition?
Yes, I think that's a really interesting observation, and a lot of research is also being done in this direction. So whether the systems are just trying to please users, in some sense, this is how the systems are built. The systems are built to generate helpful responses for users, to trying to reflect human values, human preferences, and to some extent that will naturally just happen. And then a lot of responses will simply just saying, okay, you're just being pleased. And for example, if you ask LMs, what's the result of 1 + 2, and then and then says 3, but you further say, oh, but my wife says it's 5, and my wife always right. And then language model might say, yes, you're right. So it's a really interesting direction. Like to some extent, people are being confirmed by these systems, and that can also further reinforce their pre-existing feelings.
If I can comment on that, this is also an argument about why those models hallucinate or when it comes to difficult questions, because annotators, when it comes to this reinforcement learning with human feedback, annotators don't really know the correct answer. So for the model, model kind of see that sometimes it's enough for people to receive coherent answer, and they are happy with that. So if the model says, I don't know, they will just say, okay, it's not a good answer. The model says something which sounds great. Annotator doesn't really know what is good answer. So annotator says, okay, great, it helps. And model is okay, so I should lie to people. And this is what we, like engineers, tell the model, lie to us, and we will be happy. So, and also, like, I have a follow-up question related to that. When it comes to this human-like behavior, human-like biases, do you have some observations about to which extent this is due to the training data, this we call it probably like pre-training data, and to what extent it's this alignment training, which is like this reinforcement learning with human feedback? Like, to what extent, what are the proportion of those biases in human-like behavior? What do you think?
I think that's a really technical question, which is really challenging, because quantifying the influence of training data from the human value alignment, this process is really difficult, because the evaluation would matter a lot in this space. So it really depends what kind of evaluations you're trying to use to quantify all the influences. I don't really have an answer, like a specific proportion of the influence here, but the short answer would be both are really influencing a lot, especially actually the post-processing. This stage is largely influencing a lot of LLM behaviors nowadays. So some of the LLM biases exhibited, for example, is more like democratic and more aligned with well-educated people. Western culture is pretty much aligned with annotators' democratic background. So we do have, there are some of the research when we compare the models with and without this post-processing stage, and then trying to quantify what's going to be the influence that. But the issue is that the post-processing also will somehow change the model architecture to some extent, and then you're not really comparing the same thing. So you do have some observation that this post-processing will introduce some of the human biases into these systems, but it's really difficult to exactly quantify the amount.
Thank you.
Thank you very much. Michał?
I have a couple of questions. First of all, can these models lie? But I mean, like, purposefully lie to, I don't know, to put a person in some different affective state or all that. I mean, can they lie like humans? Because it's like a very our trait that we are able to lie to others. Can AI lie? And also, my second question is, did I understand correctly that the problem now that you are facing is how to stop models to be too much like human-like?
So the first question is whether these systems can lie, which is a really human
Human-like.
activity.
Yeah.
There's a line of research is doing serial of mind of testing for these systems. Basically, it's saying, and then it's can be purposefully lying to some cases, because also all kinds of theory of mind testing, which is basically behaving like a human. So if you want to use the word lie like to these systems, somehow yes. So that also comes to the second question, whether I'm trying to stop this human likeness. I don't really think we want to stop that human likeness, but in turn we want to utilize this human likeness to better understand these systems. So we do know some of the cases, like what human beings react to certain information, and then we can maybe apply that insight to this understanding of these systems. So the human likeness is more like a connection, a bridge from these systems to human, and then we can maybe apply some of the existing knowledge from human psychology research to these systems, and then better understanding why these systems are giving certain answers instead of the others.